A PID is the classical solution to elevate the quality of your cup by improving the temperature stability and precision during your extractions. For the hobbyists pursuing their perfect cup, it also improves the consistency during the experimental process. In this video, I'll show the easiest way to install a PID in a Gaggia Classic, how to adjust the parameters, the optimal settings that I found for my machine, a comparison against the Rancilio Silvia that I have here right in the back, the results compared to the temperature surfing experiment that I made in the previous video, and one of these results was totally unexpected. And yes, I measured everything because in this world there are lots of people giving opinions without data, without experimenting, without even studying sometimes, and I wanted to check the data for myself and also to provide the data for you to reach your conclusions, to find your truth for your taste, and not making shallow analysis. The first question that you may have is it difficult to install a PID? In a Gaggia Classic, I don't think it is very difficult, but definitely more difficult than installing only the dimmer, and less complicated than installing a Gaggiuino. But you can check the installation process and decide by yourself. The second question that you may have is, if I install the PID, is it worth installing the Gaggiuino, or should I wait and go straight to the Gaggiuino? I'm documenting the performance here so that we can compare in the future. I'll install the Gaggiuino in a Gaggia, in a Rancilio Silvia, both the previous version of Gaggiuino, which is open, and the new version that is closed, but then you have a web interface, you have a larger display, and then you can decide. So if you're interested in seeing these videos, subscribe to receive the notifications. But what can I tell you before making the installation testing by myself? The Gaggiuino has some features that basically automate all the process for you. You will not only be able to control the temperature, but also the flow, the pressure. You will be able to stop your shot by weight, either using the predictive scale that is estimated based on the flow, or you may install the hardware scale, and then you will have more precision. If you're experimenting different beans, you will use different grind sizes, the flow will be different, and then you will have a different calibration. The predictive scale will not work so well, but you will be able to use the hardware scale. The other main difference is that you have a display to see all the parameters of your process, all the curves, how is it going. I think it's a much nicer implementation, I prefer, but I'm one of those obsessive hobbyists that wants to improve the cup the most I can, that wants to check all the parameters and see what's the difference that one or another makes in the quality of my cup. And if this is the case for you, yes, it's great. If you're more relaxed, maybe you can stay with only the PID. It's less complicated, it's easy to maintain, and it will provide a great cup. I just recommend that in this case you also install the dimmer and a pressure gauge for you to control the pressure and the flow in your cup. It will also allow you to make pre-infusion, and then you will have lots of tools to play with your coffee already. Let's see how to install the PID in Gaggia Classic and how it performed temperature-wise. Before we start, let me show you the electrical diagram that I built for this machine to make it easier for you to understand. If you want, you can take a screenshot now, but this diagram will also be available in my website, www.espressohackers.com, and you will also find a list of all the components and tools that you may need, with the links for you to buy those components and tools if you wish. Those links are affiliate links, most of them, and if you buy from those links, you won't pay anything more, but I may receive a small commission and you will help to support this channel, okay? When we open the machine, you will see that it's labeled with these numbers here, and then you can go back to this diagram and understand how it works. All the rationale is based on delivering energy permanently to those elements here, to those connectors here, and this will come from the brown wire connected to the plug. And the other end will come from this light blue wire that will go to the other side of those components. And it will only feed those components based on the logic behind these switches, right? So when you close this switch, when you are powering on your machine, it will deliver energy to the brew thermostat, and it will start heating until it achieves 107 degrees. It will be getting ready for brewing. When you press the brew switch, this one, it will close, and this blue wire will deliver energy both to the solenoid valve and to the pump. The switch is permanently closed, and then the pump starts working. The solenoid valve is closing, and then all the water will go to the group head. If you're not steaming, this is open, and if you want to steam, you will close the switch. This will be open, and then the energy, instead of flowing through the brew thermostat that will cut the energy above 107, this energy will be delivered to the steam thermostat that will only stop delivering energy when it achieves 130 degrees. Then the heating element will be working until 130 degrees, and you will have a lot of steam to make your latte. Then when we install the PID, we will remove the brew thermostat because we want the temperature to be controlled by the PID. Then we'll remove the brew thermostat, and the connectors that were connected to the brew thermostat will go to the SSR, to the number 1 and 2. And the SSR will only close this contact and deliver energy to the boiler when it is commanded by the PID, and the PID will use the connectors number 4 and 5 to activate the SSR. And it will do that only when the sensor, an M4 that we're going to install, informs from the number 9 and 10 that the temperature is at, below, or above the set temperature. This PID will also need to be connected to the electricity. Then one of the ends will permanently come from this number 2 as well. And the second end, in my machine, it is installed in the number 8, but you can put in the number 4 or number 11, for example. I put it here because it was more accessible, but for representation only, I'm showing that the red wire is connected to this circuit here, and it will only turn my PID on when I turn my machine on as well. And with that explained, let's go to the machine and check how we did it physically. Okay, so first of all, we are gonna disassemble the machine. I removed already the drip tray, and now remove the screws here. I have 2 Phillips screws. When you remove this lid, you need to know that there's a brown wire connected here. Yeah, so this is connected to the plate. So when you remove, be careful because you can break the wire. Before we continue, you don't need to remove all the wires if you are only installing the PID, okay? I only did because I was cleaning the whole machine. I did a complete descaling, and I needed to bring this video here for you to have a reference when you see the electrical diagram. But let's continue. So this is the power that comes from your outlet. I'm putting the number 1 here before disconnecting, and the number 2 here. Remove the ground. 3. This will be number 4. Have the ground, let's remove the ground. Okay, let's mark on all the heating elements. So this will be 13. And then we have the two connected to this thermostat. That will be the 17 and 18. Let's remove this screw here. There's a screw here that keeps the thermofuse in contact with the boiler. So these are the wires that goes to the thermostat. I'm gonna mark this thermostat 1 and 2, T1 and T2. Now I want to disconnect this steam wand. Yes, I think it's a 17. I'll remove also this thermostat. This is the steam thermostat. So I'm going to disconnect the wires from the solenoid valve. Solenoid 1, solenoid 2, and I'm also removing the cables from the pump. This is the pump 2. Second disclaimer, when I made a video about the temperature surfing, I removed the thermocouple and I put the thermostat back again. But the images are better in this video than I brought here because I think it is more illustrative. So when I am showing the thermostat, it is being installed and you will uninstall. Then you are going to rotate anti-clockwise. Same for the thermocouple, you will rotate in the opposite direction that I'm showing in this video, okay? But let's get back to the PID installation. Okay, now I think I'm ready to install the PID. So I cut the cables to the length required. Here will be the two cables that will feed the PID controller. These are the ones that will go to the SSR and connect to the PID controller. Here we have the two terminals from the thermocouple. And finally, we have the two wires that were connected to the thermostat. Here is one of them, here's the other. And those two will be connected to the SSR. You need to fix the SSR to the frame. First, let's connect to the thermostat. Doesn't matter which one. Just connect the T1 and T2 here. Okay. Right. So the SSR is fixed. Now the pigbacks. One is going here on the number 2. So I remove the number 2, the brown, and I'm gonna put the black wire with the piggyback here. First I'm gonna connect the brown, then finally I'll put it here back in place. Now the red, I'm gonna use this number 8. It's easier to place it here. Again, first I'm gonna put the connector in the pigback, then I'm gonna put it back here. This is super tight. Let me open a bit. Those connectors, sometimes they are, I don't know if bad quality, but they come totally closed. Okay, nice. I also need to send this wire to the outside. Okay, how do you set your parameters? If you want to change the temperature, you just press once the set, and then you move with the arrows to change the temperature. And then set again, it's done. If you want to change the parameters, hold for a few seconds. AL1 is for alarm. You leave it for in 0 because you don't want to change the you don't want to use the alarm function. Set again, ARU 0 because auto tuning is off. Then you can set your P minus in 30, I minus 360, and D minus 8. Then AR it's 100, I don't remember why. R is the interval that the PID is controlling the temperature, so I put the minimum, that is 1. This is the offset. Mine is set for minus 15. It's just the starting point. I'm gonna make some tests and adjust it later. This is the lock function, if you want to have it locked. And then this is the first menu. For the advanced menu, you press and hold the set and the switch, then this code is 1 and you will enter this advanced mode. I don't know if we need to change anything here. This is the type of alarm. The F I don't remember. The code, yeah. So I think that's it. And note that here I use the REX C100 to show how to install, how to adjust, for you to see the difference in appearance. Some people prefer the XMT because it's smaller, but I like more the REX C100 because I can see the current temperature and the set temperature. And I think it's easier to navigate here. And before we continue, if you can make me a favor, let me know in the comments if this video is easy enough for you to install your PID, or if it is still too complicated, because the goal was to make it easy enough for anyone to install the PID in their machines, but maybe it's not yet there. Please give me your feedback. And how better is a Gaggia Classic with PID compared to the one with only a thermostat? If you saw my video about temperature surfing in a Gaggia Classic, you saw that when you start brewing after the light goes off, the initial temperature in the puck will be 92 degrees. And if you start right after the light goes on, it will be about 100 degrees, which is too hot. And inside the boiler, the temperature may achieve 126 degrees. And depending on where you are in that curve of heating in the boiler, you may have very hot water in your cup, which will lead to a bitter coffee, right? If you didn't see this video, I'll leave the card and also the link in the description. Well, with a PID, you can set very precisely the initial temperature that you're gonna brew your coffee. You will have much more consistency because you will always start at the same temperature. And if you want to change by a few degrees, you will be able to do that with precision. Without a PID, it's going to be a bit of a guess. And despite being sufficient for most of the people, if you want to experiment and if you want to test very different beans, you will need a PID to extract the most of that bean. It doesn't mean that your coffee will be bad, but to achieve the potential that each bean has, I would recommend the PID. But in terms of the stability, with a PID, the temperature dropped by 4 or 5 degrees, which was very similar to the thermostat. And this was a big surprise for me. I wasn't expecting that the machine with a thermostat would be as stable as a machine with a PID. It happened only to the Gaggia Classic so far, okay? In my other machines, this was not the case. And my best guess to why this happens is because Gaggia Classic has a very small boiler, a 75 mils boiler. And when the thermostat kicks in, it will start at full power. The PID will slowly increase the power delivered to the heating element, because it will note that there's a difference in temperature, but it will calculate how big it is, how fast it is approaching the target temperature, and then it will increase or not the power that is delivered. And the thermostat, it doesn't know that. It just delivers full power until it achieves 107 degrees and it cuts the power. Also, we were surfing the temperature. So we were in the right slope, we were in the ascending curve, and then we took advantage not only of the power, but also the inertia. Then I think this helped the machine with thermostat to keep also the 4 to 5 degrees in temperature stability. But despite the other cons, it's great to see that a domestic machine with thermostat can deliver such a great temperature stability. 5 degrees is a very reasonable stability, and you will barely notice the difference in your cup if it was 3 degrees, for example. By the way, if you think that this video is being useful, please hit the like and share with your friends so that YouTube also knows that the video is useful and deliver it to more people. So with those great results in temperature stability with a thermostat, doesn't mean that it's not worth adding a PID to a Gaggia Classic. In my opinion, it's still worth, because with a PID you have control, as I said, on the initial temperature that will start brewing. Then you have more flexibility to use different beans and get a good coffee or the best of those coffees. And you avoid overheating. This machine tends to overheat. 126 degrees inside the boiler is almost the steam temperature. So it will deliver bitter coffee sometimes if you didn't serve correctly. And sometimes it's difficult to predict. You may think that you're doing right, but you may be a little bit ahead or behind the curve, and it may deliver bitter coffee. Another very relevant point for me is convenience. With a PID, I set for 90 degrees and forget. When I get back, I just press the button and I brew my shot. If I have a thermostat, I'll have to wait until the light goes on and off. And sometimes it's a few minutes that I'm not able to wait, or I don't want to wait, or I want to optimize my time. So not so convenient. And in my case, I like to make experiments. I like to check if the extra temperature delivered a better shot or not. And then for me, that I'm doing lots of experiments, it is important to have a precise increase in the temperature for me to compare my shots. Maybe in your case it's not, but still, it will avoid overheating. It will avoid having to wait until the machine is ready or in the right phase of the curve for you to brew your shot. And it's going to be more precise. You will know from where you're starting and why this shot today was better or worse than the other yesterday. And finally, which is better, a Rancilio Silvia with PID or a Gaggia Classic with PID? Well, in terms of temperature stability, Silvia performs better. Maybe you won't see the difference in the cup, so I wouldn't say that this is the main criteria. One problem that Gaggia has is this limited space between the group and the drip tray. It's annoying to put a scale and a cup, especially if you're using the double spout portafilter. If you're using the bottomless, you have a little bit more space. Silvia is not that much better. I think it has maybe 2 centimeters more, but it makes a difference. If you steam, Silvia tends to be much better because the boiler has 300 mils in volume against 75 in a Gaggia Classic. So you will have probably more steam, more power with a Rancilio Silvia. But there are other aspects to be considered as well. For example, maintenance. A boiler for a Gaggia Classic costs about 65 euros, and for Rancilio Silvia, almost 200 euros. It's also much easier to disassemble a Gaggia Classic than a Rancilio Silvia. It has much more screws, difficult to access, and it will take more time, not impossible, but a bit annoying. Rancilio Silvia is also famous for getting rusted, especially in the frame and under the drip tray. So if you're buying second hand, I recommend you to check at least here under the drip tray, that is easy to see, and you will have an idea of how well it was maintained, and the chance of being rusted on the other parts. And if it's too rusted, you will have to sand and repaint. But if you ask me which one I prefer, Rancilio Silvia or Gaggia Classic, I still prefer Rancilio Silvia. I think the bigger boiler, the better temperature stability. The fuel, I think the construction is better. You don't have a plastic OPV inside, for example. In a Gaggia Classic, you will only have the metallic OPV, the brass OPV, if you buy the pre-2015 or 2009. This one is 2006. But then if you need to replace that OPV, you will not find anymore in the market. You will have to convert to the plastic one, and it's going to be a bit expensive because you have to buy an adapter plus hose plus connectors and the new OPV, and it's going to be plastic. You can make another mod to add an OPV, a brass OPV to the Gaggia Classic, but it's a lot of work basically. So I like most the Rancilio Silvia, but there's no right or wrong, okay? It's more a matter of personal preference. Because if you brew a coffee in both machines, it's going to be very difficult to note the difference even side by side, because one has a temperature stability of 5 degrees, the other maybe 1 or 2, and this difference is not so relevant for regular people like us to feel the difference. Maybe side by side we'll see a little difference, but not that big to justify a very assertive decision to buy one or the other. Maybe if you steam, you get more steam with a Rancilio Silvia because it has a boiler that is 4 times bigger. But yeah, I think it's more a matter of preference, okay? Hope that you like it, and thanks for watching.